To solve a right triangle means to find the measurements of its acute angles and the lengths of its sides. To find the measurements of missing angles in a right triangle, there are two cases you have to consider. One, if only one acute angle is unknown, its measure can be found by subtracting the given acute angle measure from 90. Recall the sum of measures of angles in a triangle must equal 180. In a right triangle, since one angle is already 90, that means that the acute angles measured must have to give you 90 also, and that means that they are complementary. Angles. A plus B has to give you 90, which means that one angle is 90 minus the other. If both acute angles are unknown, you must use an inverse trig formula to find the measures of one of the acute angles, and then follow the steps above to find the other acute angle. To find the lengths of the missing sides in a right triangle, there are two considerations. If the length of only one side is unknown, use Pythagorean theorem. Again, what is that? That is a squared plus b squared is equal to c squared. If the lengths of two sides are unknown, you must use a trig ratio to find the length of one of the missing sides. You can then use Pythagorean theorem to find the length of the other sides, or use different trig ratios. Solving right triangles with two sides unknown. To determine which trig ratio to use, you must use the ratio tangent, sine, or cosine that involves two known parts of the triangle and the part you're trying to find. So let's take a look at this problem. Example, find the missing parts of the right triangle. In a right triangle, you must be given 3 out of the 6 parts. The 6 parts are the 3 angles and the 3 sides. In this case, we know that angle C is 90 degrees. We know that angle A is 35. And we know that side A is 4. The first thing I can easily do is find out what angle B is, because I know that if I add A and B together, that must give me 90. That means that B is equal to 90 minus A. And that means that angle B is 55 degrees. Next, I always try to use trig functions whenever possible. So in this case, I'm going to take a look at the angle that I'm given. I'm given angle A, and the side that I'm given is side A. In terms of given the opposite side, because this is now the opposite, that means that B is the adjacent and C is the hypotenuse. If I'm trying to find out what side B is, what trig function uses opposite and adjacent? Well, in terms of angle A, side A is the opposite, side B is the adjacent. So that means I'm going to use tangent. Why did I pick tangent? Because again, I'm given angle A and I'm given the opposite. So I'm trying to use any trig function that uses opposite in it. And since I'm looking for side B, since I'm looking for the adjacent, I'm going to use tangent. So that means that tangent of 35 is equal to 4 over B. Here's a little trick. If the variable that you're looking for is in the denominator, you're going to switch the tangent function and the variable. So I'm going to switch the B with the tangent of 35. For most calculators, all you would have to do is just plug this in. And I'm going to plug it in by saying 4 divided by the tangent of 35. And that will give me 5.71. Now, since I do know two sides of a right triangle now, I could use Pythagorean theorem to find the third. I'm not a big fan of that because one of the sides that I found was rounded, and I'm not particularly fond of using rounded numbers. So let's go back to angle A. With respect to angle A, we know that side A is the opposite, and we know that side C is hypotenuse. So what trig function uses opposite and hypotenuse? That would be sine. So plug in what you know. You know that angle A is 35. you know that opposite is 4 and hypotenuse is C. Again, the variable is in the denominator, so I'm going to switch it. That means that C is equal to 4 over the sine of 35. And that should give me the value of 6.97. Go ahead and pause and see what you can do with this one. This one says find the two missing sides and the missing angle. So in this case right here, I'm given angle B, and I am given side A. With respect to angle B, side A is the adjacent, side B is going to be the opposite, and side C is always going to be the hypotenuse. So again, I have one angle and I'm looking for the other. I know if I add the two together, it's got to give me 90. That means that A is 90 minus B. That means that angle A has to be 28 degrees. Now, in terms of the sides, I'm going to try to use anything that deals with the adjacent side, because I'm given angle B and the adjacent side. If I'm looking for the opposite, what trig function uses opposite and adjacent? That would be a tangent. So tangent of angle B is opposite over adjacent. So tangent of 62 is equal to opposite over adjacent. If your variable is located in the numerator, what you're going to do is you're going to multiply the adjacent with the tangent of 62. So this is going to end up being a product. That's going to give me 84.6 meters because I do have a measurement on side A. Now again, I do have two sides of a right triangle now that I have side B, but that side B is rounded. So I'm going to go ahead and use the trig function to find the hypotenuse. So that means that what trig function uses adjacent and hypotenuse? That would be cosine of angle B, because I am given angle B, of adjacent over hypotenuse. That's cosine of 62 is equal to 45 over C. And again, if the variable is located on the bottom, you're going to divide. So this ends up being 45 over the cosine of 62. 95.9 meters. Again, the hypotenuse has got to be bigger than either A or B. So if C would have ended up being like 70 something, something would have been wrong. For a word problem, let's take a look at a 25-foot ladder is leaning against a wall and forms an angle of 70 degrees with the ground. How high up the wall is the top of the ladder? So again, this is the ladder. It is 25 feet long. I'm given an angle with the ground, and I'm looking for the height. Now, the height is opposite of the angle, and the 25 feet is the hypotenuse. This is why sine is being used. Because remember, what is sine? It is opposite over hypotenuse. Because the variable is located in the numerator, this is why we multiplied the 25 times sine of 70. Anytime you're multiplying a side with a trig value, always put the side in front of the trig value. Using your calculator, you should come up with 23.5 feet. Next, we're going to take a look at angle of elevation and angle of depression. Important thing to realize about either one of these angles is that it's always created from the horizontal. Let's say that you're on ground level and you're looking straight ahead and you see something in the sky. You rotate upward. That is elevation. If you're on top of a cliff and you decide to look down, looking straight ahead and you look downward, that is angle of depression. The reason why these two angles are equal is because they are alternate interior angles. That's why they're equal to each other. Because if you look straight ahead, either on top of the cliff or the bottom of the cliff, they're parallel to each other. And the diagonal line would be your transversal line. So the reason why they're equal because of the rule of alternate interior angles. Now let's take a look at this problem. It says from a top of a cliff, the angle of depression to a life raft on the ocean is 39 degrees. If the top of the cliff is 100 feet above sea level, how far off the shore is the life raft? Okay, so here's your cliff. We're 100 feet up. The angle of depression from the horizontal, if I rotate downward, is 39 degrees. Which basically means if I'm standing in the boat and I look upward, it is also 39 degrees. So I have the angle from the boat to the top of the cliff, and the 100 feet is opposite of the angle of elevation. And I want to know from the base of the cliff, how far is the boat? If you have a problem where the hypotenuse is not being used, then you're always going to use the tangent ratio. So that means the tangent of 39 degrees is going to be the opposite over the adjacent. This is where they get tangent of 39 is equal to the opposite over the base. Because the variable is in the denominator, this is where we're going to switch it, and x is equal to 100 divided by the tangent of 39. And that's why we get roughly 123 feet. Go ahead and pause. See what we can do with this one. It says the building's angle elevation from a point on the ground 20 meters from its base is 35 degrees. Find the height of the building to the nearest meter. So this one again, what I would do is I would do a drawing of it. Draw somebody at the base of the building. We are told that we are 20 meters from the bottom of it. And if I look horizontally and rotate upward, that would create a 35-degree angle. We're looking for the height of the building. If you're not looking for the hypotenuse, or you're not given the hypotenuse, it will be a tangent value. So that means the tangent of the angle is equal to the opposite over the base. So the tangent of the angle 35 is equal to the height over the base. The variable is in the numerator, so we are going to multiply. Rounded to the nearest meter, the answer should be 14 meters is the height of the building.